When we look at the skeleton of a Tyrannosaurus rex, the standard narrative suggests its end was a single, fiery explosion. We imagine a giant rock falling from the sky and instantly vaporizing the world's apex predators. We assume the same fate for armored herbivores like the Triceratops. In this version of history, the asteroid hits and every dinosaur on Earth dies in a single afternoon. The actual event began 66 million years ago, when a rock up to 9 miles wide smashed into the shallow waters of the Yucatan Peninsula, traveling at 45,000 miles per hour. The kinetic energy released was equivalent to billions of atomic bombs detonating simultaneously. The initial strike triggered massive magnitude 11 earthquakes and sent megatsunamis hundreds of feet high, scouring the coastlines of the Americas. While these disasters devastated the immediate region, the Earth's curvature protected life on distant continents. For a dinosaur in what is now Asia or Africa, the day began like any other, unaware that the impact had just triggered a global environmental domino effect. The force of the impact punched so deep into the crust that it blasted billions of tons of pulverized rock and debris straight up, far beyond the atmosphere. These are tektites, tiny beads of glass formed in the heat of the blast. When gravity pulled this material back down hours later, the beads re-entered the atmosphere at high speeds, heating up due to extreme friction. This friction turned the global atmosphere into a broiler oven. The radiating heat from the sky ignited spontaneous firestorms that swept across entire continents, turning the world's forests to ash. Once the fires died down, the blackout began. Striking sulfur-rich rock, the impact created a thick shield of soot that wrapped the planet. This blocked the sun, plunging Earth into a sudden impact winter where global temperatures plummeted. Dinosaurs that survived the initial firestorms now occupied a landscape of permanent, freezing twilight. While the soot blocked the light, the sulfur remaining in the air began a new chemical reaction. It mixed with water vapor to create highly concentrated sulfuric acid. When the rains finally fell as acid rain, it scoured the land, poisoned freshwater lakes, and sharply lowered the pH of the surface oceans. This sudden acidification dissolved the shells of microscopic plankton. As these organisms died out, the entire foundation of the marine food web gave way. This is a mosasaur. Without plankton supporting the food chain, giant marine reptiles like this one starved and eventually vanished from the fossil record. On land, the lack of sunlight meant plants could no longer photosynthesize. Within weeks, the lush forests and ferns that fed the world's largest animals wilted and died. Massive herbivores starved without vegetation, and the apex predators that haunted them soon followed. Evidence suggests these carnivores turned to cannibalism before they too succumbed to the lack of food. From the oceans to the forests, the total collapse of the food web left no room for the planet's largest inhabitants. This prolonged starvation served as the final executioner. We can see the physical record of this collapse today. This distinct dark band of rock is the KPG boundary. It separates the era of dinosaurs from the era that followed, packed with the soot and ash of the dying Cretaceous world. Survival in this environment required specific traits. Only creatures that needed very little food, could eat dead organic matter, or could shelter underground or deep underwater made it through. This included insects, crocodiles, certain birds, and our tiny burrowing mammalian ancestors. The removal of the dinosaurs cleared the biological stage. The survivors emerged into a world where they could spread into new roles and evolve without the pressure of giant predators. We are the descendants of those few that survived the darkness. To explore more of the events that shaped our world, subscribe to Ancient World Unveiled.